right, today's lesson, you are going to flip open to page 196 to start with in your math textbook. So we have worked with multiplying a decimal by a whole number, and we're going to continue working on that, but in a word problem form here for today's lesson. So on page 196, sorry, you can't see it there, 196, we're going to do problems 7 and 8 and 9. Just for some practice, I would like you to follow along with us and then complete these problems along with showing your work, similar to the way that I do in your textbook as well. So you have these as problems to look back on in case you need help with something. All right, so you know what? Let's start out with just a review of multiplying decimals first. Let's do number 5. So remember, I always start with putting the factor with the most digits up on top. So I'm going to do 0.071. And when we multiply decimals, remember, we don't need to line up the decimal points like we do with adding and subtracting. I'm going to line up the last digits of each factor. So that means my 8 is going to go under here, and I'm going to start multiplying as normal. I forget the decimal point just for now, and then I multiply as normal. So I'm going to do 8 times 1 is 8. 8 times 7 is 56. 8 times 0 is 0, plus 5 is 5, and 8 times 0 is 0. So then when I am done multiplying as normal, I go back and I count how many digits are behind a decimal point in the two factors above. Well, in my bottom number, because it's a whole number, my decimal point is after the 8, and there's no digits after the 8. So I can ignore that part of, or that factor, when counting the digits behind the decimal point. But up in the top factor, I have 3 digits after my decimal point that I need to keep in the back of my mind. So I'm going to write the number 3 just so I don't forget. After I solve and I get my number or my product down below, I'm going to put my decimal point at the very right-hand side of the product just to start with. And then based off of the number of digits in the decimal points or in the factors above, I need to move this decimal point that many spaces to the left. So that means I'm going to move it 1, 2, 3. Still to this day, I have to do my little swoops here with the arrow so that I make sure that I get it in the right spot. So if I see these underneath the answer, that is totally fine because I would write mine the same way as well. So my answer would then be 0.568. Okay. All right, now let's look down at number 7. Number 7, a bee hummingbird has a mass of 1.8 grams. How many grams are 6 hummingbirds in a 4-gram nest? So there's kind of 2 parts to this. Notice how the hummingbird is in a nest. We want to see how much the nest and the 6 hummingbirds in the nest weighs total. So that means we need to add both the 6 and the 4 together. Okay. 6 hummingbirds. Oh, no, I'm sorry. Let's backtrack a second. Let's box this part of the problem here, just so we don't forget to go back to that part. But right now, I don't need to worry about it. I'm going to find out how many grams my 6 hummingbirds weigh. So that means I need to multiply 1.8 by 6. So let's solve that over here. 1.8 times 6. So again, I ignore my decimal points for now and multiply as normal as if this was 18 times 6. 6 times 8 is 48. 6 times 1 is 6, plus 4 is 10. So now I look back, I have 1 digit after my decimal points in the problem. So I write my little 1 there. My decimal point automatically goes after the last digit in my product, and I'm going to move it that many spaces over to the left. So now I know that 6 hummingbirds weigh 10.8 grams. Okay, but that's just the hummingbirds. Now we need to see how much the hummingbirds inside the nest, along with the weight of the nest, which is 4 grams, is as a total. So now I'm going to add 10.8 plus 4.0. That means that our decimal points actually need to line up here. So we need to add in a 0 at the end of our 4, and then we add straight down. So 8 plus 0 is 8. Bring down my decimal point. Think back to last week's lessons. 0 plus 4 is 4. 1 plus 0 is 1. So now my answer is actually 14.8 grams. Okay, so that one was kind of a two-step problem there. So just make sure that you're picking apart each part of the problem and seeing what you need, when you need it, and don't forget to go back and do that. Okay, let's look at number 8. Justin buys 12 pencils for 56 cents each. He pays with a $10 bill. How much change will he receive? Two things we need to do in this problem. First, we need to figure out how much these 12 pencils for 56 cents each are going to cost. Okay, the rest of the problem we're just going to ignore for right now. Let's multiply. I'm going to do it on the side here. 12 times 0.56. Put my multiplication sign over here just because I ran out of room on the side. So now I didn't write my decimal point very well there. Okay, so I know my 2 and my 6 are lined up. So 2 times 6 is 12. 2 times 5 is 10, plus 1 is 11. 2 times 0 is 0, plus 1 is 1. Now remember, when we have a second digit down here, you need to add a 0 down to fill your spot, and then you start multiplying. 1 times 6 is 6. 1 times 5 is 5. And 1 times 0 is 0. Okay, now I can add straight down. 2, 1 plus 6 is 7, 1 plus 5 is 6, and my 0. Okay, so now I'm going to go back in the problem. I see 2 digits after my decimal point. So that means my answer, the decimal point is going to be moved 2 places to the left. So that means it's in between the 6 and the 7 instead of after the 2. So that means 12 pencils equals $6.72. But now the next part of the problem says he pays with a $10 bill. How much change will he receive? Now we need to do another operation. Let's take $10 and let's subtract $6.72 from $10 to see how much change we'll get back. So now this is where we have to line up the decimal points because we're subtracting decimals now. Looks like we're going to have to do a lot of borrowing. 0 minus 2, can't do. 0 minus 7, can't do. 0 minus 6, can't do. Let's take from here, that becomes a 0. Bring it over here. Cross that off, that becomes a 9. Bring your 10 over. Cross that off, that becomes a 9. And bring your 10 over. Now we have 10 minus 2 gives me 8. 9 minus 7 gives me 2. I have to bring down my decimal point. 9 minus 6 is 3, and then 0 minus 0 is 0. So I now know that I'm going to get $3.28 back as change. Now, word problems always need to have my label. In this case, it's my dollar sign. So we are done with this problem. That was a two-step problem, so just be careful when you are reading through your word problems to see how many steps you need to do and what your first step is. Number 9, this is something that I do after almost every problem. How can you estimate products, or how can estimating products help you place the decimal correctly? Remember, that's the part that I do where I'm rounding as I'm looking at my decimal points. So if you were to look up here, I know that 1.8 is pretty close to 2. So if I were to multiply 2 times 6, I know that my answer should be pretty close to 12, and it is in this case. But it's kind of a little bit below 12, which you wouldn't really expect, but that's because 1.8 is actually quite a bit lower than 2, if you really think about it. So 2 times 6 is 12, 10.8 is pretty close to 12 in the grand scheme of things. So I know that that answer is probably correct. If I were to have gotten 108 as my answer, and I know that 2 times 6 is 12, I would probably have a red flag going, saying, whoa, 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 what is going on? My answer does not seem right. Well, then that would be a silly mistake. Easy fix, just relook at what spot your decimal point is in. Okay. Now let's do another practice problem. Let's move on to page 197, and let's do problem number 9. Now, when you are multiplying decimals by whole numbers, sometimes certain numbers that you are multiplying them by, whole numbers, make it very easy to multiply. So number 9 says the hottest temperature recorded in the world in degrees Fahrenheit can be found by multiplying 13.46 by 10. Find this temperature and justify your procedure. Well, let's multiply it. So I'm going to go over to the side, right above this little picture here. 13.46 times 10. Remember, my number with my greatest digits goes on top, and then you line up the last digits in each number. Okay, so now I'm going to go through. This round is 0, so 0 times 0 is 0, or 0 times 6 is 0, 0 times 4 is 0, and 0 times 3 is 0, and 0 times 1 is 0. That was a pretty easy round, but I need to add another 0 down here to hold my spot. Now I get 1 times 6 is 6, 1 times 4 is 4, 1 times 3 is 3, and 1 times 1 is 1. Now if I add straight down, 0, 6, 4, 3, and 1, 1, 3, 4, 6, 0. But I know that my original problem, my original problem had 1, 3, 4, 6. Let's think about that. So going back to the problem, I have 2 digits behind my decimal point in the factor included in this problem. So I know that I need to move my decimal point 2 places to the left, which means it's in between the 4 and the 6. So now my answer would be 134.6 degrees Fahrenheit for my label. Now it's saying, what do you notice about this? 13.46 times 10, 134.6. What is the difference between this and this? And I don't mean subtracting. What do you notice about this number compared to this number? Take a second to look at it. Now, if you noticed, you have all the same digits here, 1346, 1346. It's just your decimal point is one space off compared to your original number. Now, if you're multiplying by 10, quick little tip for you, or by 100 or 1000, you can actually just move the decimal point 1 spot to the right, and you will get your answer. Now, if I were to do that, 1 spot to the right, 134.6 is what we got for our answer. But we took some time to solve it over here. Quick thing, multiply by 10, you would count the number of zeros in the number you're multiplying it by. And it only works for 10, 100, 1000, 10,000. The number of zeros that you have in your multiplying by number, your other factor, is how many spaces you move it to the right. Now, if I were to say 13.46 by 100, there's 2 zeros in there, which would mean I move it 2 places to the right, and it would become 1346, my decimal point after the 6. Okay, just a tidbit of fun there. All right, now let's go to page 199, and let's do problem number 25. Problem number 25 is right below this butterfly here, and it says a sheet of printer paper is 8.5 inches or 8.5 inches by 11 inches. What is the area of the paper? In your homework tonight, you're going to be doing an area problem, so I kind of wanted to give you a little hint or a method of how to solve it. So we know that area equals length times width. So we have our length and we have our width. So we're going to multiply. Now in this case, it doesn't matter what number goes on top because they both have the same amount of digits. Okay, so multiply as normal. Ignore our decimal points for a second. 1 times 5 is 5. 1 times 8 is 8. Bring down my 0. 1 times 5 is 5. 1 times 8 is 8. And we're going to add straight down. And I'm going to actually write my answer over here. So sorry if that's confusing. 5 plus 0 is 5. 8 plus 5 is 13. And 1 plus 8 is 9. So now I have 935 below my answer, and I have 1 digit behind a decimal point in my factors in the original problem. So that means my answer is going to be 93.5. My decimal point moved 1 space to the left. So now my label for this, 93.5, is inches. But remember, when we do area, it ends up being inches squared or square inches. You can even write down as your label. area is squared with our label. Okay, now your homework for today is going to be on page 197. So flip back a page. You are going to do, just look up a little bit more here for you. You are going to be doing problem number 5, 6, problem number 8, and problem number 10 at the very bottom. Okay. Then on page 199, the page we were just on, you're going to do problems number 21, 23, and 26 down at the bottom here. These will be written down in the assignment, so just double check those. I was just showing you what problems you were doing for your homework. Again, let me know if you have any other questions. I will attach some extra practice in case you need some extra practice on there as well.